Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the third question from the May-June 2024 Physical Science Paper 2 examination. Please do expect a total number of 9 videos since the question paper has 9 questions. That means each and every question will have its own video. So please do take this serious guys. Knowing how to tackle exam questions will give you an edge whenever you write your final exam. So please do share the video to your peers so that they may have the same edge as well. We are told that the boiling points of some organic compounds are shown in the table below. The atmospheric pressure is 1.1, it's 101.3 kilopascals. Okay, we are given 4 compounds. Compound A is just a straight chain haloalkane. Compound B is a branched haloalkane. And both compound A and B are just chain isomers of one another. They have the same molecular formula, same functional group, but they have different chain lengths. And then compound C is an alcohol that has 4 carbons. And alcohol, guys, has the strongest intermolecular forces. They have hydrogen bond, so that's why their boiling point is high compared to haloalkanes, which have dipole to dipole forces in between them. And then compound D is an aldehyde, which also has a dipole to dipole forces between them. Né? Okay, so in all these compounds, compound C should have the highest boiling point because it has the strongest intermolecular force. Okay, they want us to define the term boiling point. Boiling point, guys, is a temperature whereby is a temperature whereby the vapor pressure of a substance is equal to its atmospheric pressure. Is a temperature whereby a vapor pressure of a substance is equal to its atmospheric pressure. Which one of the compounds A, B, or C is mainly a liquid at room temperature? Compound C is a liquid at room temperature. Okay, explain the difference in the boiling points of compounds A and B. If we were to draw structures for both A and B, né? Compound A will be over here. We have 1, 2, 3, 4. It's a straight chain haloalkane with 4 carbons, and it has our halogen at the terminal over there. It's a primal haloalkane. And then compound B would be like this. And also have chlorine over there. Are you together? Okay. Now, whenever, guys, we explain the difference in the boiling point, the first thing we need to do, we need to mention the difference between the 2 compounds. Secondly, comment on the intermolecular forces, or rather the strength of the intermolecular forces. Thirdly, comment on the energy that is required to separate the bonds. And then thirdly, you will write a conclusion whether which one has a higher boiling point or not. Nah? Okay, if I want to make my argument, or rather my comparison, and making compound A as my reference, I will simply say compound A has a larger surface area, or I'll say compound A has a longer chain length as compared to compound B. And then point number 2, I'll simply say hence compound A will have the strongest intermolecular forces. And then point number 3, I'll simply say compound A will require more energy to separate the bonds, and hence the boiling point of compound A is higher than that of compound B. But if I were to make a reference with compound B, I would simply say compound B has the shortest chain length, or has a smaller surface area. Then point number 2, I'll simply say compound B will have weaker intermolecular forces compared to compound A. And then I'll simply say less energy will be required to separate the bonds of compound B, and then hence compound B will have the lowest boiling point. That's how, guys, we're supposed to tackle these questions now. And then now we are being asked to consider the boiling points below the 75 degrees Celsius, 120 degrees, and 126. Which one of the following, which one of these values represent X, the boiling point of compound D? Compound D is an aldehyde, ne? And for an aldehyde, guys, the boiling point of your alcohol should always be greater than that of your aldehyde, ne? So if you compare these two, they are greater than the boiling point of alcohol. That means they are incorrect, and the correct one is this one, ne? So 75 degrees is the one that represents the boiling point of the aldehyde. And they want us to fully explain our answer. We will simply say that the boiling point of your aldehyde should be greater than that of your alcohol. Why? Because aldehyde has weaker intermolecular forces compared to an alcohol. Are you together? Remember that, guys. Your intermolecular forces, the strength of your intermolecular forces rather, is always directly proportional to your boiling point. Are you together? If the intermolecular forces are weak, the boiling point will be low. If the intermolecular forces are strong, boiling point will be high. Okay, and then now what are they saying? The atmospheric pressure is now changed into 83 kilopascals. How will the boiling point of these organic compounds be affected? Choose increase, decrease, or remain the same. The boiling point will simply decrease. By decreasing the atmospheric pressure, we will decrease the boiling point.